So imagine shrinking like a 1,500-line, super complex AI workflow down to just 45 lines of code.
Right.
And at the same time, dropping the API costs from over $3 to 26 cents. Welcome to today's deep dive, where we're unpacking a stack of academic papers, including Mass Factory and Alas, to really understand how building AI teams is completely changing.
Yeah, it's not just a hypothetical anymore. We're moving away from writing thousands of lines of code to this really fluid graph-first workflow.
Right, because before we even talk about the factory stuff, we have to talk about why the standard agent loop is basically dying.
Exactly. I mean, anyone building in this space knows the main point. You usually have a single LLM trying to do everything serially by reading this massive, ever-expanding context window.
Yeah.
And the fatal flaw is, well, unbounded recovery.
Unbounded recovery. So, like, if it hits an error, it just spins out.
Right. It gets trapped in a hallucination loop because the whole history of its failed attempts just gets dumped right back into its prompt.
Oh, man. So it's basically like a single overwhelmed chef trying to cook a 10-course meal alone in a chaotic kitchen, and eventually they just lose the plot.
That is a perfect analogy, actually, which is why developers are moving to structured graphs.
Yeah.
Things like langgraph or ALS.
Where it's more like a fully staffed, well-oiled restaurant kitchen. Right, like every station is working in parallel.
Yeah, exactly. In a graph, the nodes are specialized, executable agents.
Yeah.
And the edges are dependencies. They act like a physical conveyor belt locking in the exact state between those stations.
So if one specific step fails, you don't have to reset the entire kitchen.
Right. You get state isolation. By forcing the workflow into explicit edges, you are mathematically restricting what the LLM can process at any given node.
Oh, wow.
Yeah, it only reads the specific inputs defined by that edge. It doesn't have to parse a massive context window of its own past mistakes.
Which totally kills those expensive infinite loops.
But, okay, let me push back a bit here.
Yeah. Manually hard-coding every single node and edge in a complex graph. That sounds like a massive engineering bottleneck.
Oh, it absolutely is. And that is exactly where Mass Factory and this concept of vibe graphing come into play. Developers needed a way to automate all of that orchestration.
Okay, but wait, how is vibe graphing different from just, I don't know, vibe coding? Where you just ask an AI to write an application and it basically spits out a brittle wall of text that breaks immediately.
Well, raw vibe coding tries to generate execution code directly, right?
Yeah.
Without any underlying architecture. Vibe graphing is different because it generates an intermediate representation first.
Like a structural blueprint.
Exactly. You just describe your intent in natural language, and the system compiles it in 3 specific stages. First is role assignment, where it figures out the necessary agent personas.
Okay, that makes sense.
Then there's topology design, which maps out the exact directional edges for how those agents will actually communicate.
And the third stage is semantic completion, right? But how does it actually bridge the gap between a high-level design and executable code without just hallucinating everything?
So semantic completion uses an LLM to automatically generate the required API schemas and the distinct system prompts for each node. It basically writes the localized functions so the node can operate inside that topology.
And it makes sure the data types match across the edges before it even tries to run.
Right. But crucially, a human stays in the loop.
Oh, yeah.
You review these generated visual nodes in something like a VS Code extension.
Oh, wow. So you literally see the graph.
Yeah, you inspect the nodes, verify the schemas, and if it looks good, you just type agree to proceed. You catch the architectural flaws before a single token is spent on execution.
Which goes back to those insane metrics we started with. Reproducing the chat dev workflow manually took 1,511 lines of code with this explicit visual structure, 45 lines.
Yeah, it's wild. You're snapping together reusable, verifiable components instead of writing bespoke orchestration logic from scratch.
Which completely shifts what it means to build these systems. You don't have to be a hardcore, low-level bricklayer anymore. You're operating more like a high-level project manager.
Exactly. You're orchestrating teams of agents rather than writing their individual loops.
So to wrap this up, let's think about the future. Because there's some wild recent research on reinforcement learning for multi-agent systems, where AI is being trained to learn orchestration on its own.
Yeah, models are learning the optimal moments to dynamically spawn a sub-agent, delegate a task, and then terminate that agent when the node is complete.
Right. So if the factory eventually learns to autonomously hire, manage, and fire its own digital workers based on real-time task demands, at what point does your role shift from project manager to just being the customer waiting at the end of the conveyor belt?
That is a very real possibility.
definitely something for you to mull over as you build your next workflow. Thanks for joining us on this deep dive.